So today we're going to talk about functions. The first thing we need to study is the set in which we are going to consider these functions. In this case will be the set of real numbers. Let me recall the following sets of numbers or systems of numbers. And to start with, let's look at the natural numbers. And 1, 2, 3, etc. After that, we often add them, and then soon enough we start subtracting. And in that case, we have to consider a new concept, which in this case would be the zero, and going into debt or negative numbers. So the set of integers is composed of the natural numbers together with the zero and negative numbers. Then the following steps is of course multiplying these integers, and as soon as we start multiplying, then we start also dividing. And for example, right away we get that if we try to consider 1 divided by 2, the result is not an integer, and the result is a fraction or a rational number. So the set of rational numbers is the set of fractions, the set of quotients, P over Q, where P and Q are both integers. Now the real numbers contain all of the above sets. Basically, we have the naturals are contained in the integers, which are contained in the rationals, which are part of the real numbers. Now, we will not do it here, but the set of numbers that are real but not rational, often called irrational numbers, is huge. It's actually bigger than the set of rational numbers. A couple of examples, actually 3 examples of numbers that are not rational are square root of 2, pi, and e, and there are many, many others. In a future class of advanced calculus or math reasoning, we can at least see why square root of 2 is not a rational number. For now, we'll just continue. Now, in calculus, in this class in particular, we are going to consider subsets of the real numbers. This symbol over here that looks like a C together with a horizontal line is called a subset, and it's basically all the numbers that are possibly real, but maybe not all of them. Now, finally, to get to our definition, we need first actually some notation. A function will be denoted by the letter F, and then we say we need a D, which is a set that we will call the domain. We need an R. We need another set, which is called the codomain. And a function basically assigns assigns a number for every number in the domain. So in other words, for every element of the domain, there is a unique element in the codomain assigned to the original one. In other words, x gets an f of x. Well, that's how we call it. So x gets assigned a number related to x by the function. So now these assignations or these designations are often algebraic in the sense that we do some algebra, some multiplication, something. So often we can write f of x is equal to something. So let's do some examples. I'm sure you have seen them before, but let's see. Let's do some examples. The first one and the easiest one that I can think of is function from the reals to the reals. In other words, the domain of f is the real numbers. The codomain is also the real numbers. And the way we assign an element to x is simply by saying x is going to 5, or the number assigned to x is just 5. So every single number in this domain gets a unique number assigned to it, which is 5, only one. Although I do have to agree that 5 is being assigned to every single one element of this domain. So here I wrote the domain of f is of course the real numbers. Every x gets a number. The codomain is the real numbers. The other set that I didn't mention earlier, but I can mention it now, is what is the range or image of the function? In other words, what are the set of values? What are the numbers we are assigning to the elements in the domain? In this case, turns out to be just the number 5. So it's a very easy image. Another example that is relatively easy is the one where we assign to every x in the domain, we assign the same x in the codomain. So in other words, g of x is just equal to x. And by the way, I use the letter f to define the function, but in reality, we can use any letter in the alphabet. So here I chose g. So g of x is just x. The domain, once again, is a whole real number. Every real number is getting a number in the codomain. Actually, it's the same x. So g of x is equal to x. Now, in this example, the range or the image of g actually is also r, right? Because we are getting every element of r gets the same element in r. So in this case, it's actually not too difficult to see that the image is just the real numbers. The next example, let's say age, also from the reals to the reals. In this case, every x gets assigned the square, its square. So, for example, I can do a bit more. For example, 1 goes to 1. 2 goes to 2 square, which is just 4. 3 is going to 3 square, which is 9. I can do more. 1/2 would be going to 1/2 square, which is 1/4, etc. 0.1, for example, would go to 0.1 square, which is 0.01, etc. Oh, also negative numbers, right? I almost forgot. So minus 4 goes to minus 4 square, which is 16. So minus 1/3 would go to 1/9, etc. So once again, in this case, the question is age a function? And the answer is yes. Every x gets a unique a unique number in the real numbers in the codomain is just the square of x. There's just one square, right? So x squared. The domain is the reals, so every x gets somebody. The codomain is the reals, that's almost a given. And what is the image in this case? Well, since we are squaring and all the results are squared, we notice that then all of these numbers are always positive. In other words, the range or the image of the function h is actually all the numbers, all the real numbers that are greater than or equal to 0. Okay, so example 4. In this case, I called it j. And I'm saying, maybe I should write it with words. X is assigned its square root. X goes to, well, it's written there. Okay, so is j a function? So, well, let's do a few examples. The first thing is j of 0 is equal to 0. Yeah, the square root of 0 is 0. In other words, the number that when you square it, you get 0 is 0, yes. How about 1? So, what I want is the number that when I square it, I get back 1. So, definitely 1 works, because 1 squared is equal to 1. But notice that minus 1 also works, because minus 1 squared is also equal to 1. So j of 1 would have to be 1 or minus 1. Actually similar to any positive number, let's say 4. What is the square root of 4? Well, it's any number that when you square it, you get back 4. And so 2 squared, of course, is equal to 4. So that's why j of 4 could be 2. But also minus 2 squared is equal to 4. So j of 4 could also be minus 2. So that means that j is not a function, because there are these numbers, actually any positive, but in particular there is, let's say, 1 that could have two assigned elements in the codomain. J also fails to be a function for another reason. Notice that J of negative numbers are actually not defined. In other words, J of minus 1, for example, would be the square root of minus 1, which is not real. It's not a real number. More generally, J of a negative number, again, is not defined because square roots of negative numbers are not real.